Good morning or afternoon, everyone. Welcome to today's webinar, ERock Talk, a biopharmaceutical industry roundtable about mitigating risk with a resilient facility design. My name is Megan Parrish. I'm the senior editor for Pharma Manufacturing Magazine, which is producing today's event. And today's event is sponsored by Enchanted Rock. Today, we're going to talk about how biopharma companies are being faced with unprecedented challenges as they manage operations and the expansion of manufacturing capabilities in the U.S. amidst the ongoing coronavirus pandemic, and how, in order to achieve these efforts, facility design flexibility and operational resiliency are critical to mitigate risk. While biopharmaceutical facilities have always valued crisis-proofing operations, contingency strategies and technologies are becoming the new norm in facility design. So in this industry roundtable discussion, we are bringing together a panel of experts to share what steps they are taking to safeguard manufacturing facilities and answer several key questions such as, what is the economic risk of power outages? How can facility design minimize risk in the pharma industry? And how can power resiliency be considered a competitive advantage? To complement this discussion, we will have a Q&A session after the roundtable presentation. Please note that attendees are in listen-only mode during the presentation, but you will be able to submit questions during the Q&A session at the end. Now, before I introduce our panel, there are a few housekeeping issues that I'd like to review. On the interface we're using for this webinar, you'll see several different boxes or sections. The upper audio section allows you to adjust the volume. Just hover over this section until you see the audio volume control, and you'll be able to adjust it. Below that is the very important Ask a Question/technical support box. During our roundtable discussion, you can type your question for our panel right here, and they will get to your question during our Q&A session at the end. Also, if you're having technical problems, you can simply type your question or concern into this box as well, and one of our technical engineers will help. In the largest section of today's presentation, you'll see our slides displayed. And then below that, we have a live chat box. Now, this is a really good place to chat with other webinar attendees, but please note that this is not a good place to submit a question for the Q&A section, because that's not where we're going to go looking for those. Also, you can always enlarge a section by clicking on the square box on the top right corner of the section next to the X. But if you accidentally close a section, don't panic. You can always get back to it by clicking the corresponding icon button on the left-hand side of the screen. Please note that this webcast will be archived. We do encourage you to direct coworkers to the recorded presentation. It will also be available on the Pharma Manufacturing website. We've also recently added a Q&A feature to our on-demand presentation so that listeners can ask a speaker question and it will be passed along for them. And one final important note, we ask that you please respond to the feedback form at the end of this presentation. Your answers will help us improve future events. Now, I'd like to go ahead and introduce today's panel. First, we have Alan Scher, who is the Chief Commercial Officer at Enchanted Rock. Alan has over 30 years of experience in commercial and industry energy services and handles corporate and product marketing as well as sales at Enchanted Rock. We also have Tom Pagliuco, the Executive Director of Global Energy Engineering at AbbVie. Tom is a 40-year industry veteran who handles the energy management program at AbbVie across a global facility portfolio. Next, we have David Tier. He's the Senior Engineering Manager of Viral-Based Therapeutics at Lonza. David has been working in facility management and engineering roles at biopharma companies for over 25 years and is an expert in many areas, including cGMP, cell and gene therapy manufacturing, and more. Finally, we're joined by Jerry Irwin, the Senior Project Director of CRB. Jerry manages project profitability for biotechnology projects at CRB and has been in the construction management business for over 30 years. And with that, I'm going to hand the floor over to Alan, who will lead you through the roundtable discussion and the Q&A session at the end. Take it away, Alan.
Well, thank you, Megan, and thank you to all for joining today. We have an excellent panel, as you've heard, for the next installment of Enchanted Rock's ERock Talk Roundtable Series, Mitigating Risk with Resilience in Facility Design. We've got 3 topics that we're going to be covering throughout this webinar. As we go through each one, I'll be steering questions to some of the panelists, and then we're looking forward to your questions at the end. So let's get started. The first area relates to the changing electric grid and the need for business resiliency, and I'd like to start with Tom. Tom, the need for electric resiliency seems to be getting more attention in the industry. What's causing all the concern about the grid now?
Yeah, so a couple of things, just some recent, things that have happened. Number one was California. We saw rolling blackouts affecting a lot of the state. We saw fire and smoke issues creating problems with renewable supply. So that was kind of the cause of blackouts. Also recently, we have a couple sites in New Jersey that lost power because of a couple of storms that have come through. So with the advent of, severe weather changes, it's definitely putting a lot of stress on the grid. It's making site resiliency even more important. Some sites aren't protected as well as they should be. It just creates all kinds of problems. It doesn't take much to cause a problem in pharma. If you lose power even for a short duration, it could be an issue that has to be reported and/or cause a batch to be scrapped. So power reliability is relatively important in any industry, but it's probably even more important in the pharma industry.
I'd like to get into a little more of that, Tom, in another question related to what happens, what are those costs of an outage. But first, let me turn to David. David, you're manufacturing for others, and I thought maybe you could comment on how does a power outage affect your relationships with those clients? What are their expectations, and how does resiliency play into your competitive advantage? Go ahead, David.
As a CMO, Lonza is basically a service provider. When people come to manufacture with Lonza and utilize our skill sets, they expect us to have mitigated and basically mission critical type facilities is what they expect. Having those conversations with a power blip those are conversations that are not fun and don't need to be necessary with your clients if you design your facilities correctly. All pharma facilities are mission critical facility. We have tons of man hours into these one of a kind products, and if we have a blip within those manufacturing processes, things come into question that may not be able to be answered. And that's a hard conversation to have, and that's not one that you want to have with a client.
Yeah, I'm sure that's the case. Let's steer the conversation a little bit toward the industry's traditional practices of using conventional diesel backup for meeting resiliency challenges. I think it's common practice that diesel backup is what would be normally turned to. What are your experiences with the performance and fuel supply chain of that option?
So historically, facilities have been around the tried and true, backup power generation with diesel gensets. The larger facilities, the more power density you get into these buildings, the larger your generators, the more diesel fuel storage you have to have. Your larger tier 2 reporting structures, there's safety issues, there's contractual obligations that you need to deal with your diesel supplier to make sure that you're first in line and prepared to, weather any storms that may be hitting into a Gulf Coast region or depending upon where the storm may be coming from. Those are all critical items, but again, you're somewhat limited footprint. At some point in time, you have your regulatory requirements with diesel generators that you potentially don't have with gas, cleaner burning type of fuel emission items. The tier 2 reporting, especially with your safety officers and making sure you have your spill kits, there's wide-ranging, items that come along with diesel generators that people don't want to always discuss up front.
And I'm curious, in the case of Jerry, your clients, this has been a crazy year in a lot of ways, right? 2020 is one we want to look back on, not dwell on. But are you hearing from your clients when they're talking about facility expansions or retrofits or new construction, are they raising this issue about resiliency from the power grid more often than in the past, or is it the same?
It's quite a bit more often. The antiquated grid system that we all have to contend with has become a real risk for any pharma manufacturer. And I know at CRB we do our best to try to mitigate, as much risk as possible by looking at the best options. Here in South Texas, with the storms that we get, the outages we get because of the grid system, design-wise, we are constantly looking for new and improved ways to mitigate the risk just because of the amount of loss of product that is potential to our clients. And that has increased now in the world of COVID where, everyone is working feverishly to come up with a solution.
So let's shift to that topic. Let's move to what those options are for mitigating risks related to resiliency. First, Tom, let's go back to you. Take us through a power outage, one that you can recall. Just kind of walk us through what happens when the power disruption occurs, the different parts of the business that are affected, and if you can, give us some ballpark estimates of how costly that is. And then, David, I want to do the same thing with you. Go ahead, Tom.
Sure. So I think there's a couple areas that can be impacted by a loss of power. The traditional one, or the one most people think of, is inventory. So you've made some product. It might have to be stored at, cold temperatures. If you lose power, you lose chill water, you lose your temperature excursions go up, and you lose product. So probably if you look at a facility, if there's going to be backup generation, it's going to be to cover whatever is deemed to be critical, and that's probably going to be around the inventory. But recently we've seen some power outages at our sites that have caused loss of production. This one site in particular actually had the inventory backed up, but they didn't have the ability to run air handlers and chillers in the processing area. And so it was over the summer, and it would get really hot in those areas, so they couldn't manufacture. And they lost power for 3 days. It's a sold-out situation, so there was really very little ways to make up the loss of production. They couldn't run an extra day because they were already running 7 days a week. So, that in that case depends on the product, but you're talking millions of dollars. The other issue you could run into on the production side is quite often a plant has, a certain time limit to process the raw material. Otherwise, you have to reject it and you can't use it. So even if you backed up your cold storage, for instance, if you still can't get to the raw material to convert it into product, you've lost it, and that can be equally as costly. And then there's the issue we talked about a little earlier about lost batches. You're in the middle of a batch, and if you lose power even momentarily, it could cause the batch to be scrapped, and that's also certainly in the millions of dollars, especially in some of the biologic products that are being made. So, outages can be extremely expensive. They can also be annoyances from a reporting standpoint at the minimum, and, millions of dollars probably at the other end.
David, how do your experiences compare with what Tom just related from this summer?
Tom was spot on. All of those endeavors happen when you're manufacturing the batch. When we build these buildings in these, mission critical N+1 redundancy, we try to identify as many of your Achilles heels, your incubators, your cold storage, your walk-ins. But at some point in time, there's a cost-benefit ratio. You can't back up everything. We can't back up the whole building. It's not cost-effective a lot of times, and the amount of generators that you'd have to bring on site and the amount of fuel that you'd have to keep on site to keep all these running, it's astronomical. So you pick and choose what your Achilles heels are, whether that be an incubator, cold storage, whatever, and you back those items up. But as Tom mentioned, if you're in the middle of a batch and you have a blip, even if you have UPSs in between the generator to handle those blips in real time, it's still a blip, and it calls into question your manufacturing item, what you're doing at the real time. Your QA will get involved. You'll be doing investigations. It's a lot more man hours and going through, and it may be a determining factor of scrapping that batch, which has lots of man hours involved with it as well. And these are one-of-a-kind products a lot of times, and it's not something that is replaceable that we can get out of the fridge. It's starting a batch over, and that's timely, costly, and painful. And on top of having to have that conversation with your customer that we had a blip, and it called into question your product that we were manufacturing for you. So it's reputation as well.
It just reinforces how dependent we are on what we take for granted with the grid, and the grid is not capable of giving you the level of resiliency that you're looking for. Let me ask Jerry the next question. Clearly, this risk is something your clients are asking about. What are the options that you're evaluating to be able to address this risk when you're putting together a design program for a customer?
Well, we look at, traditional diesel generator, UPS systems, or switch over, but now we're starting to graduate more towards natural gas rather than diesel. We're looking for cleaner power. We're looking for more resilient power. And we're also starting to look very deeply into microgrid patterns for campus design facilities, where a lot of our clients might have 4 or 5 plants on one area, where we go into the microgrid, and it's a benefit tremendously from what we can see with the data we have. You don't have to worry about your diesel supply chain. The chances of natural gas not flowing is considerably low. It helps mitigate the cost risk even during design. The ability to, have your client out the gate understand the fact that power has been mitigated to the point where their plant and their traditional manufacturing styles can remain and not have to worry about a storm, a flood, in order to keep manufacturing and moving forward, or at least get the product in a stable format, is quite a benefit, and it comes up in risk assessments on a continual basis with all of our clients.
As the moderator, let me take the prerogative of just giving a little background on the microgrid that Jerry introduced, so that everyone can be up on the same page. A microgrid has very many similarities to a backup diesel plant, with some differences that are important. On one front, a microgrid is designed to provide that level of backup when the power is disturbed, but it also can generate a revenue stream and provide continuous power for often for a much longer duration than the typical diesel storage might suggest. So that a microgrid gives those kinds of advantages over a typical diesel backup. But let me turn to Dave and Tom. You guys have been looking at alternatives. What do you like about the microgrid model compared to what you're looking at or currently using?
Yes. So the analogy I'll use is like it's an insurance policy. So it's the traditional backup generation that you install and you hope you never run is kind of like term life, life insurance. You're buying life insurance just in case you die and you want to leave money to cover whatever costs remain, versus whole life, where at least you're making an investment, but you're also for insurance purposes, if you will, but you're also getting some financial benefit from it. Where I started to gravitate towards is, well, why make an investment in an insurance policy of backup generation when there's possibilities to put that asset to work for you, be it maybe a true microgrid, or maybe it's a CHP system, or just something that runs for resiliency, but also can get some economic advantage, which will either reduce the cost of the asset in the first place, or help give you some payback to offset the cost of the assets. It feels kind of crazy to, like I said, spend all that money and just have the assets sit there. Occasionally you got to run it, but have it just sit there and not really generate any benefit other than insurance purposes.
Yeah, Dave, how about you?
Yeah, absolutely. I agree with Tom 100% on all of those accounts, and I like his analogy of the term life. There's a few more advantages that you see you buy and you put these expensive backup power generations, paralleling switchgear, multiple generators, and then you have to maintain that. So it's a lot of maintenance costs that go along with that over the life cycle of that equipment. Where I started gravitating toward the microgrid and really looking at Enchanted Rock and becoming enamored with it was that as we're building these campuses and trying to do these master plans for future pharma growth, generators are always going to be a part of that. So the infrastructure is needed and necessary. So that's got to be a part of your design intent. The microgrid, some of the situations where it can grow with you. Today, I may need 2 modules to cover my building. I don't have to spend it today to prep for the future. As we grow and we get closer to what we know, not what we think we know, it can grow with us. Obviously, having line quality power that you're selling back to the grid coming into my building versus a diesel generator where sine wave is, somewhat, sketchy at best. So it doesn't put out a clean power voltage. Not having to maintain the life cycle of that asset as you're taking care of your equipment on our site. So that gives us some operational dollars back. So I think more pros than I do cons with the model that Enchanted Rock has been offering, and quite frankly, the growing with a facility over the time is a huge advantage over having to buy diesel generators and put the infrastructure in to keep bolting on more as you build out more buildings, you build out more infrastructure. Your power needs change over the life cycle of a building, and being able to move more nimbly than just throwing a diesel generator out the back door and worrying about the noise levels, the reporting, or regulatory questions that are come with your diesel generator. Some of that just goes away, especially with the microgrid model. There's a lot of advantages that I see from a facility standpoint.
Let's ask the same question of Jerry. You're the design professional here on the panel. When you're doing a design engagement, how does this flexibility and future expansion plans factor into the options that you consider?
Well, we consider this option on just about every master plan we're looking at right now at CRB. We like the growth. We like the ability to think of, it's more of clean burning incentive packages to the client, but to be able to have a technology that is dependable, with your program Enchanted Rock, not having to worry about the service, the maintenance, the upkeep on your program, that relieves our clients of a lot of infrastructure needs as far as facility and labor, regulatory requirements, and it's line quality power. And that means a lot to our clients. You're talking about plants on a master plan facility group that could be in the hundreds of millions of dollars worth of product being manufactured at one time. And that doesn't even constitute what's going into cold storage units and environmental controls throughout the buildings or anything else. That's just product. And this, again, to reiterate what the guys have said, is a very good insurance policy to be able to depend on Enchanted Rock system in order to do that. So we find our clients very receptive. They like the ability that the system can grow with them. And actually, it's becoming very cost effective for them during the planning phase.
Let me remind the participants on the call that we're taking questions. We've got a few that are coming in from the audience. We'll get to those in a second. I'd like to move to a couple of other, one more question that I've got for the panelists. This microgrid idea sounds like it could be more complicated than just buying some diesel generators and putting them at the site. There may be some advantages, but how do you feel about the complexity? And maybe I'll start with Tom. How do you feel about the complexity of this idea of a microgrid?
Yeah, so I'm a huge fan of outsourcing that part of it. So we've talked to Enchanted Rock, and I think one of the business model is interesting in the fact that energy and this whole microgrid notion is your business. We're in the business of making pharmaceuticals. So having you own, operate, and maintain the system, to me, seems like a good way to get economic advantage of it, help the grid situation and the resilience of just the overall power supply for the neighborhood, if you will. and have somebody whose business it is to know when to run it, how to run it, and make sure that it's available. Because a lot of times with, I know we've touched on this, you make an investment in a backup generator, and if it's not maintained properly, when you need to use it, it may not operate properly or at all. I think, kind of outsourcing this microgrid, from my opinion, certainly a huge plus. I don't think it's a core, competence of most facilities. Even at CHP, I'm kind of a big proponent of outsourcing, operations of that. Just I've seen so many sites struggle with properly running those systems that make a better way to kind of deal with the whole thing.
Well, that's certainly our perspective here at Enchanted Rock. So thank you for that. Let me ask one more question, then we'll get to the audience questions. Jerry, you mentioned something about natural gas being cleaner. How do the sustainability policies of your clients factor into the considerations you've got? And then maybe Tom or Dave, if you want to comment on the same issue related to your company's sustainability policies.
Sustainability is key. It is a design requirement for CRB. Again, I can't reiterate enough that being able to build a plant that, is conscientious of the fact of, clean burning energy, the utilization of technology for operations, being able to use a system where our clients don't have to have mechanics within facilities and the constant maintenance and upkeep, where your program, takes care of that for our clients. It's extremely cost effective over a life cycle, and that's what we try to relate to a lot of our clients, is the fact that you have to look at the global picture, the life cycle of the plant, the life cycle of the whole facilities group. And, even if the cost directive is a little bit more on the front end, the overall advantages outweigh just about everything that we have found to date. We're recommending that on a continual basis as an option to our clients, is using, a natural gas system, to use a microgrid on a campus design. And we see a lot of campus design. A lot of companies have a future growth projection. Being able to grow with your system means a lot to our clients.
Tom, do you want to comment on the sustainability topic as it relates to AbbVie,
Sure.
the new company?
Sure. We have two key sustainability goals that kind of enter into this discussion. One is to reduce our carbon footprint 25% from a 2015 baseline by 2025. And there's a lot of different ways to do that. Reducing your energy consumption is one of them, but also there's a lot more products nowadays like REX to reduce your carbon footprint. The other one we have is 50% of our purchase electricity will be from renewables by 2025 and 100% by 2035. I saw a question about combined heat and power, CHP, and let me preface it by saying I'm a huge fan of CHP, but the issue we're going to start to run into is, and in the quote unquote old days, a CHP system had economic advantages, but it also, because the grids were relatively dirty, had a carbon advantage because it's a more efficient way to produce electricity and heat. As grids get cleaner, what I'm finding is CHP starting to cause issues as far as, carbon footprint goes. It's actually, it can increase the carbon footprint of the site instead of going the other way. Here again, depends on what grid you're in. And then also the need for 50% or 100% of your purchase electricity coming from renewables is also going to start to have an issue because, here again, back to the carbon side of it, you've increased your scope 1, your fuel source, because that's how you're making your electricity. And there's going to be a big push, once everybody starts going renewable on the electricity side, what are you going to do about your fuel side? And that's going to make combined heat and power a little more, difficult. Additionally, what I'm starting to see is and one way to meet your renewable is to go electrification and then, provide that with a renewable type of electricity. So that's just going to make resiliency even more of an issue, because now more and more equipment is going to be electrified instead of, traditional. Probably, I say in farm, it's like 60% electric, 40% natural gas or fuels. I think as sustainability, has always been important for pharma, but as the grids get cleaner, it's going to affect the way we run, I said, combined heat and power options, or even some of the resiliency backup systems. It's becoming more and more of an issue, I think.
Yeah, fascinating. Hey, Dave, as a CMO, your clients are probably asking you about your sustainability policies, and maybe you can comment on that and how your thoughts of microgrids factor into that.
Yeah, absolutely. So clients, inquire with their questionnaires on what are we doing to be a good neighbor? How are we trying to mitigate our carbon footprint, as Tom said and Gary alluded to, which is, this is on the forefront of Lonza's thought process, regardless of clients. Lonza as a whole wants to be a good neighbor to all of their facilities. Anytime we have a new technology of this microgrid that we can do it cheaper, cleaner, be a good neighbor, it's a win-win-win across the board on all of them. So we're always looking out at what can we do, not only as a company, but as also a service provider. How can we do it better, cleaner, cheaper? Frankly, that's always one of the goals, but still attain the same quality levels. And with products that are being provided by Enchanted Rock is a new alternative we didn't have in years past to look at and evaluate, which is, exciting to us. So looking forward to more discussions and more people learning about these new product offerings.
Terrific. Well, let's move to the questions from the audience. Thank you, Tom, for taking the one on CHP. Let me pick up the next one. Question was, can you provide an order of magnitude cost estimate on the difference between diesel versus natural gas and microgrids? Let me make the first comment, if I would, and then if anyone else would like to add their experience. But diesel backup generators generally are in the, call it $400, maybe plus or minus up to $500, depending on the emissions controls that are on diesel generators. That is per kilowatt. And natural gas as a substitute, on a direct substitute, tends to be a little bit more expensive than that because of the displacement of the engine. Natural gas equipment is more expensive than diesel, although the fuel is less. The microgrid idea, that concept, is that natural gas equipment can make a revenue stream where the diesel equipment cannot, and that revenue stream more than offsets the premium. So while the diesel might be in this $400 to $500 per kilowatt range, and natural gas could be $700 to $900, the net cost in the model that we work on, the net cost actually drops below that $400 to $500 range. It can be $100 to $200 in certain markets where the economic considerations of the use of the microgrid and selling services back to the grid are high enough. That is in the Northeast. It's in the Texas market, in the California market, and then there are some select other markets that have that same opportunity in the Midwest. So it can be a lower cost, and often is a lower cost than the diesel, and it's cleaner, and it's more reliable given that it's a managed service. So I don't know if Dave or Tom or Jerry, you'd like to add on your experience with those cost comparisons?
Comparisons are spot on. The one thing, like I said before, you have to look at the full life cycle of a project and a plan, not just day one cost. And if you look at the life cycle and you factor in the labor, the maintenance, the upkeep on the diesel generator, you'd be surprised to find out that, your overall cost for a natural gas fired generator and a complete system leaning towards the growth factor of a microgrid is actually beneficial because, or decreases your risk, increases your insurance policy on being able to provide clean energy for your plant.
Completely.
Dave or Tom, do you have any?
Yeah, I
Go
completely
ahead,
concur
Dave.
with Jerry's assessment. It's like you said, you've got to look over the 10-year life cycle of that asset. So it's not just load banking every year to ensure that it's working. It's the monthly maintenance and the testing, the diesel fuel, making sure that diesel fuel is clean on a regular basis, that it doesn't foul. So there's a lot of maintenance costs. By offsetting that to somebody else's responsibility, you're taking care of an asset that you need a cleaner energy source for less money on site that has a quicker turnover rate than my current ATS on a diesel generator. Again, seems like a win-win-win across the board financially.
I'll throw in another aspect of diesel versus natural gas. I think diesel was originally used because sites could store it and they would have an inventory in case something happened. But what we saw during Hurricane Sandy was that you couldn't get diesel after a couple of days or fuel, of any kind. So the issue became how do you operate even with diesel? I think natural gas provides less opportunity to go out of service, so I think the reliability is greater. So I think having natural gas backup is less risky in this day and age than having diesel power.
Yeah, thanks, Tom. Let's move to the next question. Natural gas is cleaner, but what about those businesses that have a commitment toward carbon neutrality and the elimination of all fossil fuels? How do microgrids fit into that strategy?
What we were trying to propose with the Enchanted Rock solution was to only run it for resiliency purposes and also to maximize the benefit. I think it's a good compromise between trying to get the most out of your asset and just running it when it's appropriate. I think you're always going to have some level of fuel requirements, even if we totally electrified everything. I don't think everything can be electrified. This may just be one of those examples where you just need it for backup supply.
Let me add on that, if I could, because we've done the analysis in certain markets about the use of renewable natural gas. And for those that are not sort of up the curve on that, renewable natural gas can be harvested from animal livestock farms, dairy farms, hog farms. It can be harvested from landfills, and it is, in fact, carbon neutral or even carbon negative in some cases, because methane, if it's vented into the atmosphere, is far more damaging than carbon dioxide. So we've looked at the analysis of using renewable natural gas in these microgrids, and since they don't run very often, even the price premium for that fuel can still allow them to be more cost effective than a diesel alternative, given the few very high value hours that they tend to run. So there is an opportunity for carbon neutrality in microgrids, and there are some papers on this topic on our website around decarbonizing resiliency. I'm not sure if anyone else wants to comment on that, but we'll move to the next question. So do you actually see traditional backup power eventually vanishing and shifting to microgrids? Let's see, that's a question probably for David and Tom.
Absolutely. If there's a better advantage, an opportunity than a diesel generator, I'm not only the natural gas genset, a smaller footprint, a lower cost, a lot of benefits to the operations. Storage of energy and trying to hold on to power, fuel cell technology, once it becomes financially viable, I see that being a part of the equation to help solve long-term issues. But I can see the diesel generator with regulatory issues, fuel costs, going away as better opportunities arise to achieve the same level of redundancy.
How fast do you think that can happen, Dave? Will businesses replace what they currently have, or is this primarily for expansion and new construction?
I see it first and foremost on new construction as word gets out and we start having that. As gets more mainstream, I can see going backwards to clean up some of those items. As your environmental health and departments and safety mandate you to do it better, do it cleaner, and be a good neighbor. I can see going backwards. I don't see that initially right now. I think the onslaught will be for new construction and expansions. But at some point in time, groups will be looking backwards and saying, hey, now that we have taken the step, can we mitigate and get rid of the older technology and backfill that with the newer technology that will add cost benefit to the operations and redundancy for your clients and your current operations?
I don't know when the grid's going to go away. I think they're going to coexist for a while. There'll be microgrids and then there'll be the grid, in large part because policy, isn't in effect to really make the microgrid the way to go. I think there's always going to be the grid involved, and especially as the grid gets cleaner, then it's going to be more acceptable from a sustainability standpoint.
In a way, the opportunity for microgrids to help clean up the grid is very direct. Those very few high-value hours that a microgrid can operate to generate a revenue stream, what they're really doing is helping integrate the volatility of the supply equation that's changing as traditional power plants are shut down and more renewables get on the grid. That level of intermittency on those new supplies of electricity require that kind of balancing services that microgrids can provide. Tom, you're pretty familiar with the national grid conditions. Where do you think microgrids find their best opportunity for value across the U.S.?
Well, in pharma, Puerto Rico is certainly an area that needs help from a grid standpoint. Actually, microgrids might be the best solution for Puerto Rico. California's become an issue, like I said, with all the blackouts. And then you have your Northeast states because of weather. Florida, same thing, because of hurricanes and Gulf Coast. I think where weather events can affect the grid, the microgrids will have a more important place.
Tom, does your analysis show that the weather risks are increasing as we see more climate change evidence in the market, or is that just a fiction?
Well, I don't have any hard facts to say for definite, but I do think, anecdotally, it seems to be maybe not occurring more often, but certainly in larger effects. Like I said, we had a tropical storm come through this summer in New Jersey, which typically shouldn't have caused a problem, and it knocked our site out for 3 days.
This is also anecdotal, but maybe Jerry, you and David, having some Texas operations, you can comment on this. We've noticed a lot of pop-up storms. These are severe weather that are not forecast. They just, within a couple of hours, blow up into something that's fairly significant. I think the derecho that hit Iowa is kind of an extreme example of that, but we've seen it in Texas pretty frequently that severe weather can cause pretty significant damage, and that's difficult to plan for.
Impossible to plan for. The Gulf Coast are subject to anywhere from 2 to 40 inches of rain at any given point in time, and possibly high winds, although we have a little bit more latitude with seeing that. But it's fairly, as Tom said, maybe it's not increasing the amount, but some of the intensity of what we're seeing rain-wise, wind-wise, lightning-wise seems like it can be attributable to something. Maybe it's just that we're getting older and paying more attention. But some of the, we've had a lot of named and unnamed storms this year. So this year was obviously, fairly unpredictable. And we've always had to stay on the ball and keep up with the news and pay attention to what could happen.
We're all learning a new Greek alphabet set of letters.
Exactly.
Yeah, go ahead, Jerry.
Yeah, I was just going to say, follow up with what David was saying. With the weather in southern Texas where we're at, those pop-up storms can happen at any moment. We had one client that had an issue where he had an outage. The generator did not function like it was supposed to. And, whether that was due to poor maintenance or whatever, but there was a mechanical issue with the generator. Subsequently, they lost product. And, for something that was only a half an hour outage, ended up costing a great deal of money. The idea, I think, is coming around, especially from the design side, from us to our clients, that you need to think about your location, what you are, your outside influences, whether it be the weather, so that when you're doing your design, your upgrades, even your growth patterns early on, it might behoove a company to go ahead and get rid of that diesel generator and put in something towards the line of natural gas, enchanted rock, even on an older plant system, and mitigate the risk and let that system grow and change with the plant just because of these little pop-up storms. 30 minutes doesn't seem long in a lifespan, but 30 minutes in the lifespan of a pharmaceutical production run is critical.
Let me just add one more comment on the pop-up storms. We offer to our customers the ability to proactively island from the grid when they see a hazard approaching. And we only need a few minutes notice, but because the microgrid is fired up to be grid synchronous or parallel to the grid, we can start it, island the customer from the grid with no disturbance, and then they can ride through without any interruption that pop-up storm or major event would otherwise cause. Typical diesel generator, the air permits allow that proactive islanding to occur. All right, we're getting close on time, and it looks like we've answered all of the audience questions. Let me just point out that there are some white papers that might be of interest to the attendees. One of them has to do with a comparison that the National Renewable Energy Lab did on comparing diesel to natural gas for backup generators. And the second one is on decarbonized resilience. Both of those are available at our website, www.enchantedrock.com. So feel free to go there and download those and other papers. With that, I'm going to pass it off to Megan to close up the webinar. Thank you all again for attending today.
Great. Thank you so much, Alan. Thank you so much to all of our presenters for that really wonderful and interesting roundtable discussion. Thank you so much to our attendees for listening in. I hope you enjoyed everything. Just a final reminder to the audience, please let us know your thoughts on this presentation by answering our brief survey, which will appear on your screen shortly. Your candid answers are very appreciated, and they really do help us craft future events. Also remember, this webcast will be available at pharmamanufacturing.com. Feel free to log in to view it again, or please share it with colleagues. We will also send out an on-demand link for this presentation shortly. We also encourage you to visit pharmamanufacturing.com to gain access to even more tools and resources aimed at helping you achieve on-the-job success. And on behalf of Pharma Manufacturing Magazine and the folks at Enchanted Rock, thank you for your attendance and have a great rest of your day.